Good afternoon. Good afternoon and good evening to those of you joining us virtually from afar. My name is Louise Huang, and I have the privilege of directing the Center for Research in Science and serving as the interim dean of the College of Liberal Arts and Sciences here at Azusa Pacific University. Our center hosts regular science and faith events on contemporary, complex topics. This time, we attempt to address a cultural divide, a schism in Western society. 20th century British physicist and novelist C.P. Snow described this division between science and arts in his famous Two Cultures essay and lamented such a phenomenon. It is because of this very notion I had the privilege of meeting our plenary speaker, Dr. Mitch Stokes, in a 2-year endeavor called Bridging the Two Cultures of Science and the Humanities, organized by the Scholarship and Christianity in Oxford, SCIO. And I will properly introduce Dr. Stokes shortly. Let me first point out a few housekeeping items. You can start by submitting questions for our plenary speaker and panelists using an email. And the email is S as in Sam, Huang, H-U-A-N-G, @apu.edu. I'll repeat, S as in Sam, H-U-A-N-G, @apu.edu. We are saving the Q&A during the panel discussion that will start at 5 p.m., so you're going to have to stay. We will not be passing the microphone around, and we will only consider submitted questions, so I hope you will remember that. There will be a short refreshment break between the plenary and the panel discussion around 4:50. And now, it is my distinct pleasure to introduce our plenary speaker today. Dr. Mitch Stokes is a senior fellow of philosophy at New St. Andrews College in Moscow, Idaho. Make no mistake, Dr. Stokes is not merely a philosopher. He was trained in mechanical engineering and graduated from the University of Florida with his bachelor's degree summa cum laude. He went on to earn his master's in mechanical engineering, studying gas turbine emissions using low NOx, or nitrogen oxides, combustor. At this point, seemingly Florida nor engineering could no longer hold him. He then migrated to New England to earn his master's in religion at Yale University with the renowned scholar Nicholas Wolsterstorff. Perhaps that was when philosophy finally got Dr. Stokes' attention, that he earned another master's degree and his doctorate at the University of Notre Dame, where he studied under Alvin Plantinga and Peter van Inwagen. So 5 degrees and many assignments later, Dr. Stokes specializes in history and philosophy of science, epistemology, liberal arts, STEM pedagogy, and more. He's an author to numerous articles and books, including Calculus for Everyone, Understanding the Mathematics of Change, and How to Be an Atheist, Why Many Skeptics Aren't Skeptical Enough. Dr. Stokes has received many honors and awards. To name a few, his book, A Shot to Faith, was named Resource of the Year by Outreach Magazine in 2013. In 2018, he was invited to deliver the prestigious Albert A. Holtman Jr. Memorial Lecture in Science, Engineering, and Mathematics at Grove City College. Most recently, Dr. Stokes received a Templeton Religion Trust grant as a principal investigator for the project Beauty, Physics, and Human Evolution, with collaborators Art Lewis, Mark Harris, J.P. Moreland, and William Lane Craig. So you see, I can go on and on about Dr. Stokes' accomplishments, but I'll rather give him the time to help us learn to think more deeply, to hold things in tension, and to use our God-given intellect to point to God's infinite wisdom, truth, goodness, and beauty. Would you help me give a warm APU welcome for the very first time to Dr. Mitch Stokes.
Thank you. Thank you so much, Dr. Kwon. Thank you. It's great to be here. Good afternoon. As you can tell. Let me make sure I have the... You probably gleaned that I'm going to be talking about bridging the two cultures, the science and the humanities. Sometimes I'll refer to it as STEM and humanities. But before we get into just the more the abstract ideas, I wanted to start with a concrete example of what it might look like, or what it does look like, if you don't bridge these two cultures and you keep them segregated. This is just one of many kinds of problems that can occur, but I wanted to start with something concrete before we went into things that were more abstract. So I'm going to call this Exhibit A. I only have an A. I don't have a B. But so about 10 years ago, maybe more actually, Stephen Hawking, the great physicist, wrote a book, The Grand Design, and with Leonard Mlodinow. And the point of the book was to answer the ultimate question of life, the universe, and everything, which is a lofty goal. This is an important goal. It's something that I think we all need to work on. We're probably working on for the rest of our lives. But I find this book and I think, great, lots of philosophy. This is going to be fun. I enjoy that kind of thing. But it turns out, unfortunately, he says this, traditionally, these are questions for philosophy, but philosophy is dead. I had just gotten a Ph.D. in philosophy, and so I just read, and this was disheartening. Philosophy has not kept up with modern developments in science, particularly physics. Scientists have become the bearers of the torch of discovery in our quest for knowledge. Okay, so I mean, great. I'm all for the science part, but I was a little disappointed to hear about the philosophy is dead. Now, here's the interesting thing. Hawking and Mlodinow go on to do a lot of philosophy. All right. In fact, I think it's safe to say that they actually start the whole project with philosophy. Reminds me of this tweet from a while back. This was it. So from Existential Comics, if you remember. So why does philosophy matter? I don't know. Why does science matter? Well, because science, and you're doing philosophy. So just to say, hey, philosophy's dead, okay, well why think that? You've got to come up with some reasons for thinking that, and those are typically philosophical reasons, all right? So here's this, one of the great minds of our time, answering these and dealing with these really, really important questions, and yet not realizing that he's doing the very thing that he just declared died. And what he ends up doing, he also goes on to tell us that physics, particularly M theory, which is a type of conglomeration of string theories, we'll talk more about string theory in just a bit, but not a lot. That M theory tells us that there's no God. We don't need a creator, that we can just get the universe from quantum fluctuations and what. Anyways, you'll just have to take my word for it. It's not great philosophy. It's not so much that he says, all right, we don't need a creator, that's bad enough, but it's the fact that he gets there in a way that's not a good way of getting there. So that's really the big problem here. And I think this is because of this lack of integration. If you don't even know that you're doing philosophy, you're probably going to do it poorly when you do it, all right? And it reminds me of the old quote from Francis Bacon. It's true that a little philosophy inclineth man's mind to atheism, but depth in philosophy bringeth men's minds about to religion. My point isn't so much that we need philosophy or we need I mean, it's that too, but it's just the general integration of the disciplines. If we don't understand the big picture, how that makes us kind of these lopsided sorts of thinkers. Now, it could be, though, that maybe it's just a matter of not knowing what philosophy is. I mean, that's kind of a difficult question. You know, if someone says, well, hey, what's philosophy? It's kind of, well, here's my wife says this after my talk sometimes, like, maybe you ought to say what philosophy is, because you keep using that word and people might not think it means what you think it means. And I, wait, what? Well, of course, some people don't like it. What? That's crazy. But so here's a definition of philosophy. A route of many roads leading from nowhere to nothing. So that's Ambrose Bierce, 1862. I get it. I totally get it. And philosophers, oftentimes, they have it coming to them when they get those kinds of definitions. But really, it's nothing more. I say nothing more. This is a lot. Answering the big questions. The big questions of life. So, how did we get here? Why are we here? How should we live our lives? What should we believe? How did the universe get here? Why are we and the universe like this and not like some other way? So simple questions, right? Those are easy questions. Here's one thing one way I like to describe it. This is the Flammarion engraving. It's one of my favorite metaphors or pictures or illustrations of what we're trying to do when we're answering these questions. I call it the human project. And so what we have is within the globe, within that little snow globe, you have all the things that we see, just that you observe. It's just the way we navigate the world, okay? And then beyond or behind this veil on the other side of the snow globe is what explains why things look this way. All right? And it'd be nice to be able to do what that person is doing, is stick your head beyond the veil to see. But it's really, what we're trying to do is more like looking at, so another analogy would be the face of your watch, and all you have is that, and you want to work out the workings of the watch, but you're not allowed to take the face off. Okay, so that's what we're trying to do, and oftentimes we get, and we're going to use all kinds of resources, including science, to do this. So sometimes it's really hard to constrain the domain of philosophy, which is why you have all these different disciplines within philosophy, like philosophy of science, philosophy of mathematics, because you're really just thinking more fundamentally about these other disciplines as well. And they're not hermetically sealed. Now, this can be a difficult process, right? I mean, this is, and sometimes it might seem more like this. Right? That's like, that's what's going on. Now, there's actually a different, here's a safe definition, one that we can refer to and lean on and will become important. Look, I don't know how to define philosophy, but whatever it is what Plato did in his dialogues. So if that's what he's doing, that's philosophy. And you say, well, that's not philosophy. Okay, fine, call it something else. But that's what we're going to be talking about. When I say philosophy, keep that in mind. All right, so now let's talk about this two cultures aspect. All right, and as Louise pointed out, the phrase two cultures comes from C.P. Snow's Reed Lectures from 1959. You can see here Mr. Snow is bridging those two cultures nicely there. So you have science and humanities, and he was a chemist and he was also a writer, and he would hang out with both kinds of folks, and he noticed as he's hanging out with both that they don't talk to each other, and they have these totally different ways of looking at the world. But it's not just that they have different ways of looking at the world. They have no idea what the other thinks about the world. And his concern was, look, that's bad. I mean, we all want to get along and we want to, we want to integrate personally, right? I mean, that's great. But he says it's actually worse than that. What's really at stake here, I don't know if it's worse, but it's certainly additional, is that science actually is done, it's not done as well because of a lack of understanding of the humanities. And the humanities are done poorly, or at least not as well as they could be done, because they don't know science. So there's something to what Hawking said, that maybe philosophers haven't kept up with physics. I think that there is some of that. So it goes both ways in that, humanities needs to learn some substantive science, and not just because they need to know what their friends are doing across the hall in different departments, but so that they can do humanities better, and vice versa. Now, here's what he says. He says, look, education isn't the total solution to this problem, but without education, the West can't even begin to cope. Now, so 1959, Cold War-ish. I mean, think about where we are now. I mean, maybe everyone can always say this. It's like, I think we're worse off in some important respects even now. So, but without education, the West can't even begin to cope. All the arrows point the same way. Closing the gap between our cultures is a necessity in the most abstract intellectual sense. That's true, as well as in the most practical. When those two senses have grown apart, then no society is going to be able to think with wisdom. This wisdom, it's not just knowledge, it's that too, but it's also, how do you apply knowledge? How does this affect your life? And how do you understand the big picture? And often, and you know this, we call this siloing. So you have silos and you have these disciplines, and you see this, and this is really strange to see it in the university, right? I mean, so you have diversity, unity and diversity, and you want to have this, the universities are trying to put everything together and unify all of these things. But we've come to have this kind of siloing. And of course, we know that we have to categorize, we have to separate things. We can't just go, all right, well, it's one big mush. There's no such thing as a discipline anymore, and you're not allowed to name your classes. You're not allowed. You just have to call them liberal arts 1, liberal arts 2, or humanities 1. Whatever it is, we can't do that. That's so you have to have categories, but it's when you think that they don't affect your category. So here's the solution: integrate. So you start integrating the categories, the disciplines. All right, that's really not saying anything other than stop siloing, right? I mean, we talk about integration and we think that's important, and we know that that's important. We know there's something to it, but it's like, well, okay, I know that I'm to integrate. I have that inkling. How? How do I do that? That's the thing. It's kind of like when you have a baseball player and you're coaching, he's not hitting the ball, and you go, come on, hit the ball. Look, I know that. I don't know how to do it. Teach me how. So here's one of the things I want to at least just give you. So in good writing and good storytelling, they show, don't tell. So let me try to do that. I'll try to show you a couple of things in terms of how to integrate, or my idea of how we integrate. There's going to be multiple ways. There's going to be lots of, I'm just going to take one example, but it's going to be a pretty substantive example and a far-reaching example. All right, so the first one is I want to give you, the first thing I'm going to do is give you a concrete example of integration from contemporary physics. And it's actually a problem. It's showing you that integration is necessary, and it's right at the front lines of physics. It's this notion of using beauty to determine truth in physics. All right, so, and we'll talk about that. The second thing is I want to argue and show you, hopefully, that this topic of beauty in physics, that's right there at the front lines of physics, is central to the entire liberal arts tradition and is actually baked into the liberal arts. All right? So in other words, I can rephrase them so beauty in physics now, and then beauty in physics then, a history. I want to give you a history of that, right? So the beauty and physics now. All right, physics in a nutshell. All right, this is my apologies to physicists. I always have to say that. But general relativity, so we have these two pillars of physics. You can say, all right, here's all of physics. You have general relativity. Einstein comes up with that at the beginning of the 1900s, and that describes things that go very, very fast, close to the speed of light. And it's our theory of gravity. So it replaced Newton's theory of gravity, and it's an odd, wonderful, beautiful theory, and we won't talk too much about it, but that's just one pillar, okay? The other is quantum mechanics, which describes the very, very small. And it too is very weird, very bizarre. Both of these have kind of changed our understanding of what the world is like, and had very important implications for philosophers who have paid attention, okay? So here's the problem, though. When quantum mechanics and general relativity come together and talk about the same things, normally they're talking about different things, and they're remarkably accurate. I mean, when physicists talk about it, it's kind of hyperbolic. You're like, that's kind of overdoing it. But it really is very, very, very accurate. But when relativity and quantum mechanics talk about the same topic, they can disagree. They say different things and contradict one another in these important ways. They don't work together. So there's a sense in which at least one of them is false. Okay, so that's a problem, and that physicists have known about this for years, decades. What we need is we'd like to take our theory of gravity, general relativity, and turn it into a quantum theory because we think everything is quantum. But they don't go together. So the problem here is that we don't have a quantum theory of gravity. We don't have a unified theory of everything. Now, the leading candidate for this, you've probably heard of string theory. I mean, other than when I mentioned it before, but in general, you've heard of it. It's where, things, just the time, I mean, everything's unimaginably small in quantum theory, but even smaller than that, things are made out of, the subatomic particles are made out of vibrating strings. Keep in mind, just stick a pin in it, vibrating strings, okay? Now, one of the problems here is that there's not empirical data that can tell us whether or not string theory is the right theory. So not experimental data. The theoretical physicists go and they do a bunch of math. And you want that mathematics to be confirmed with experiment, right? That's just how science works. Now the thing here is that, well, why work on string theory if you can't test it? And it's been worked on for decades. What justifies all of this work? There are a number of things, and there are good reasons, but one of the main reasons is that it's a beautiful theory. That's how it's justified by string theorists. It's beautiful. It's so beautiful, it's just got to be true. But we would need, the empirical data, the experimental data, as I said. We're running low on it at the particle collider that we have, the big one, I say we, humanity, has in Geneva, Switzerland, the CERN Large Hadron Collider. Does what it says, takes these hadrons, slams them together, and makes other particles. Well, you need a lot of energy to do that, and that's how they test for these different particles and discover new particles. In order to test for string theory, we would have to have energies that are just so far beyond anything plausible right now, there's no chance in the foreseeable future that we can actually do that. So these higher energies are needed. So then, how do you justify as the data, you can't discern using the data, the empirical data, what do you use to tell whether or not a theory is on the right track? Well, what you do is you use non-empirical data, and that's not new to string theory or anything like that. We've always used non-empirical data, things like logical consistency. You want a theory that is logically consistent, right? But then there are these other theoretical criteria that physicists have always used, but are coming under scrutiny now because of this decade's kind of stagnation. Like, wait a second, this stuff isn't working. And it's because the physicists are saying, well, we want to find a beautiful theory. Well, beauty's not working. So, but we have to rely on things like symmetry, simplicity, elegance, unity. These things that are often now called, they're aesthetic. And there's this problem, like what on earth, how people are questioning now, physicists are questioning now. Let me show you. Why would you do it that way? Why think that's going to work? So there's this debate over whether beauty should be used in contemporary physics, at least with particle physics. Is it really a reliable guide to truth? And then, and you can see there's a book in 2018, Lost in Math, How Beauty Leads Physics Astray by Sabina Hassenfelder. It's a great book, and if you just want to understand the terrain of contemporary physics, this is a good book to sink your teeth into. She's an atheist, and so it makes sense that she would say, well, how would we explain a human ability to do this? Her question is, and lots of other folks, how would we explain a human, why should primates be good at physics in this way and use beauty as this guide to the subatomic realm? So that's the question. And so right now what they're doing is there's this debate, they're fighting over the very idea of science, the scientific method. Are we even doing science when so there's this kind of crisis that is right at the forefront of physics, and this is a philosophical question. All right, we're talking about, science doesn't answer it, it's kind of like chess. The rules of chess don't tell you what the rules of chess will be. It's only once you decide on those rules, then you do chess by those rules. Well, similarly with science, once you say, all right, well, what are the rules of science? Now, it doesn't mean that scientists can't say, but it's a philosophical part. And you say, well, is it really a philosophical issue? Okay, let's go back to our definition. Well, whatever Plato did. All right? So that brings us to the second part, where I talk about physics and beauty in the beginning. Okay. Now, real quick, So going back to that. So there's all this, there are a bunch of things, right? Out in, the Greeks, they were very, if nothing, observant. They noticed there's lots of stuff in the world. Lots of different kinds of stuff, lots of different things. And that these things change. They're not stagnant, they move around, and that makes life interesting. But it's not willy-nilly, it's kind of this order to it too. Acorns always grow into trees, oaks, and not into alligators. And you think, well, of course not. Of course we're not going to do that. That's actually, we just take that kind of order for granted. There's a lot of order that we just take for granted that, logically speaking, doesn't have to be that way. Anyways, so what the Greeks were looking for at the very beginning, and probably humanity in general, even, was this: what makes sense of all this diversity, change, and order? And so you have this notion of unity and diversity, and they had this idea of an arche, this overarching principle that tied everything, all the different things together, something that unified it and made it coherent. And so philosophy starts off with that problem, this problem of change, looking for an arche. You think monarch, it's this ruler kind of thing, this overarching controller. Thales, first philosopher, says that it's water. The arche is water, and we're not going to go into why or anything like that, but everything's made of water, and maybe it was because water can be ice, it can be solid, liquid, it can be a gas, but it unified everything. And then his pupil comes along, or someone else said, no, it's not water. I mean, you know how students can be. It's not water. It's air. And then another philosopher comes along and says, you know what, it's not air, it's the apeiron, the unbounded. So they had legalized pot in Greece at that point. So you can see this kind of takes an odd turn. And this kind of keeps going on until you get to the Pythagoreans. And the Pythagoreans say, no, the arche is numbers. Okay, I mean, you think, well, that's, why? What reason would you have for thinking that? Well, let's talk about it. So what the Pythagoreans are known for discovering is that the musical intervals can be described with simple numbers, not complex ones, not like intricate ones, like just whole numbers, like 1 and 2. So you have a string, let's say you have a guitar, you pluck it, it's an E, you hold it down right in the middle, you pluck it again, it's also an E, like a 12th fret, but it's at an octave higher. And so you have this ratio of lengths of 1 to 2. So what the Pythagoreans discovered was that this music that they didn't discover music. They knew music was beautiful and they knew what sounded good and all of that. And then they found that you can characterize that with mathematics. We love music. We can characterize it with mathematics. This looks user-friendly. I love numbers. So all is number. And so that's kind of how it came up. And so they had this idea that there's this mathematical cosmos, and they may have even coined the term cosmos, and actually our word cosmetics comes from it. So there's this aspect of beauty built into the idea of a cosmos. So there's this order in the cosmos. It's mathematical and rational. It's also aesthetic or beautiful, cosmetic, and it's also morally good. There you have truth, beauty, and goodness right there, built into cosmos. And they get this from noticing that math is applicable. All right. And so they have this idea, all is number, harmonia. There's this idea of proportions and harmony. When you think of harmonia, think of, they meant its fittedness, how these different parts fit together in an appropriate way. it's kind of like think of a triad chord. You know, you have these three notes that you can hear if good musicians can hear the individual notes, but also the notes together that make something even more beautiful than those things apart. And yet those three parts keep their individuality. That's think Trinity. I mean, like, it's hard not to be pulled into that sort of idea, this notion of harmony, but that becomes really, really important. And that's the way they said, no, that is the cosmos right there. And if you've ever heard of the music of the spheres, they thought, no, there are these spheres that all the planets are on, it's all moving, and kind of like you take like a wine glass, fill it with water, and rub that, you can get the resonance and the vibrations that you can make. That's what they're thinking that the cosmos does. Now what they're doing though is so it's mathematical, it's musical, it's beautiful, all of those are the same thing, okay? They had this, what's called the tetractys. This is where they probably got this as a tattoo. This actually is the perfect 10 number, 4 on each side, and you can see that it represents octave, 5th, and 4th. And so tetractys is really important. Now, why do I care about that? Well, Plato was a Pythagorean. He learned from the Pythagoreans. And in fact, in the Republic, you probably have to read that. In books 6 and 7, so Socrates is running around trying to find out what's justice. People are giving him an example, like here's a definition, here's a definition. No, that's not it. He's not looking for particular cases. He's looking for a definition. What is justice? And so that's where you come up with this notion of the forms. That's one manifestation of it. It's like, what's the form? Not a particular case of a just act. What is justice? All right? Now, you need to be able to define. So he's going around wanting to know what are these fundamental aspects of reality. And he says, look, if you're going to be in the Republic, he's wanting to come up with this idea of the city-state and who to rule it. Well, he says, well, the philosopher kings should rule it. Because what they need to do is they need to understand the forms. So when a case comes across their path and it's a new case, they need to not just have an example of justice from before. They need to know, okay, I have the form of justice and I can apply it to this specific case. So the philosopher kings need to know the forms. They need to be able to categorize the world, these important concepts. And ultimately, they want to find the form of the good. Okay, so all this is, so how do you train the philosopher kings? Well, Plato says, here's what you do. You have them do mathematics for 10 years. And you think, oh my gosh, you're serious? I mean, like, that's so odd. You're just reading along Plato, minding your own business, it's philosophy, and next thing he starts talking about, to be a philosopher, you got to do math. Now, why is that? Well, so this is where the 7 liberal arts are introduced into, or at least 4 of them. The liberal arts are introduced into the West in these books 6 and 7. The trivium, you have the language kinds of disciplines, but then you have this quadrivium. And the quadrivium is arithmetic, geometry, astronomy, and music, or harmony. All right, and you think, well, that's out of left field. Well, where did they get it? He got it from the Pythagoreans. So he thinks training in these areas, whatever he thought of these, was somehow going to make someone a good philosopher so they'll know things like justice. And he thought that studying mathematics is kind of this form of sanctification. Your mind becomes rational and good and beautiful like the cosmos. Then in the Timaeus, what Plato does, remember philosophy? Plato does this. Plato says, hey, he has this whole, Timaeus is kind of weird, but it's this mathematical cosmos that's very Pythagorean. And there's this legend of Plato giving his academy this homework assignment where he says, hey, you know what I want you guys to do? Look, the heavens move, there's all this motion. I think there's order behind it. In fact, I think there's mathematical order behind it. So here's what I want you guys to do. Let's say you're the academy. I don't want to sound Plato, but like you're the academy. And like, all right, here's what go out and map the heavens with mathematics. But here's the kind of mathematics that you have to use. Uniformly moving circles. Any size you want, any speed you want, but they have to be circles. Now, why? Circles are symmetric. They're the perfect, they have an infinite symmetry. And symmetry is beautiful. Let me say a little bit about it. So symmetry, you might say, generally, it's change without change. So let's say you have a square. You have a square and you rotate it 90 degrees. You've changed it, you've rotated it, you've made this transformation. And then, but it also stays the same, it looks the same. Well, with a circle, what you do is, so with a square, you can only do that 4 times. With a circle, you can do it an infinite number. I mean, like you just enter in infinity, that's going to win all kinds of approval there. But that's an infinite amount of symmetry. So you can see here, there's this spatial symmetry that they're interested in. And that's why they're choosing these spheres. You can also have, look at this, there's a mathematical symmetry. We look at the formula is distance, just let's say this, d equals 16t squared. Okay, fine. But if you plot it, you see that there's a symmetry behind this abstract mathematical view. Symmetry becomes so important. In fact, physics is going to be built on symmetry. But notice, before I go on, notice how the liberal arts got introduced. We just slipped that in there as we were talking about beauty in physics and the applicability of mathematics. All right. I'll skip some of this. Some of these things I was putting in here because I'm just so excited about. Like I want to share it. I want to go, hey guys, check this out. This is really cool. But some of it I'll hold back. Finite element. I'll hold off. All right. So would Plato silo? I mean, it doesn't seem like he would. This is where the liberal arts came from, is this applicability and beautiful math going together as you're applying it to the physical world. The scientific revolution, actually, I'll skip through some of these. This was just going to show you that Pythagoreanism and Platonism came up in the scientific revolution. It comes up in the Enlightenment, like this is what people are responding to. But I want to get to something that's really, really amazing. You have the new physics of the 20th century. Einstein and others say, look, I couldn't have done all of this general relativity, quantum mechanics, and whatnot without relying on beauty, following beauty to discover these truths. In fact, you could say, well, maybe physics could be kind of like physics is beauty. It's conservation laws are like conservation of energy, conservation of momentum, are built on these mathematical symmetries. Those are fundamental principles. And you have, even string theory is supersymmetric string theory. And like, it's not just symmetric, it's what? Supersymmetric. So symmetry is really important. Okay. I'll end with this. I wanted to just show you the discovery of the omega minus particle. Murray Gell-Mann in 1962, he's the one that came up with the quark model of particle physics. He plots these different particles, like delta minus, these all stand for these particles that are made up of quarks, I didn't know it at the time. He plots them in this odd way, this triangular way, plots charge and a property called strangeness. And like, you're just thinking, okay, this is weird. This is crazy Pythagorean stuff, it sounds like. It's based on this kind of symmetry, SU3 symmetry. And what he says is, look, I can plot all of these, but there's an empty spot down at the bottom. I think there's a particle there. Go spend your money, experimentalists, on finding that. And he somehow convinced them. And sure enough, there's an omega minus particle at that. Now, none of this is physical. This is all abstract mathematics, doing stuff on paper in your mind. It's not, things don't look triangular in the world. He goes on to win a Nobel Prize. Remember that? I'll make it a little eat. Again, 10. The same, and I have no idea if that's, I've never read anywhere where Gelman looked at that. But the Pythagoreans would have really, really loved it. All right? So I'm just going to keep this up because I want to, that to me is just amazing. So I've given you two examples. I've shown you. Philosophical issues are so important to physics, and I think vice versa. And it didn't just happen recently. This goes all the way back to the very founding of this kind of liberal arts tradition in the West. So as we're trying to think about, okay, how do we stop siloing and bridge the two cultures, that's not easy. I mean, there's a lot to, it was hard, it was difficult in Plato's time, it's way harder now. But we see that there's something there that's not a hokey ad hoc way where you're just trying to I'm just going to try to figure out how all this stuff is related. I happen to like humanities, I happen to like science. How can I put them together? It's like peanut butter and chocolate. I'm going to just force them together. But you don't have to do that. It's actually built into the very humanities liberal arts tradition. Now, what it's going to take, though, is us figuring out how to flesh that out in all these different ways. I'm not telling you how to do it, but I did show you examples of why it's important and how it's been done and how it's central to what we're doing at universities. Thank you. Do we want to, did we have, for the,
Thank you, Dr. Stokes. We will now take a short break and see you back here for the panel discussion in about 10 minutes. Refreshments are out the door in the hallway and restrooms are out on the right. So we'll see you in 10 minutes. And if you want to submit questions, would you email them to shUang@apu.edu. Thank you. All right, welcome back, everyone. As we've anticipated for this panel discussion, and it's my pleasure to introduce the panel to you. We have a moderator who is Dr. Bradley Peanut McCoy, whom we refer to as Peanut on this campus, and he is a professor of physics, department chair of math, physics, and statistics. And then we have 4 students who will discuss different questions, whatnot, and also share their opinions. So I'm going to start with the one next to Peanut. Isaiah Cheng, he is an engineering student, also a STEM scholar. Maya Vargas, next to Isaiah, is a math major, also a STEM scholar. And then Sam Genoe, he is a psychology major and honors humanities student. And Camille Campbell, chemistry major and double major in honors humanities as well. Of course, we know Dr. Stokes. So I'm going to turn the mic over to Peanut.
Thank you, and thank you all for our panelists. Just to set a little bit of expectations here, in our honors college at APU, we highly value what we call colloquies, in which we read books, and then we come together as a class and just have discussions about the books and all of the tangents that that sometimes brings. So we are essentially going to be doing a colloquy here related to Mitch's book, as well as some of the ideas that came up in the plenary. If you all have questions, you may send in questions as well. The email for the questions is up there on the board, swong@apu.edu. It's hard to read. We had a dying marker. Sad. Okay, so to get us started here, related to this 2 cultures, in the book there is, Mitch, you raised the idea of this fact-value divide. And some may take that as the facts is the thing that the sciences do, and the values may be more of the thing that humanities do. Of course, gross oversimplification. But I'm wondering if all of you could weigh in on why is it valuable to make distinctions of what questions are questions of fact and what questions are questions of values. Camille, you look like you might want to go first.
I think one of the reasons that it's important to distinguish between these 2 ideas is because oftentimes I feel like in our different disciplines, we can easily segregate, like you were saying, fact for science and more of the STEM fields and value for more of the humanities fields. But if you really look at them in more like deeper, basically, you see a lot that fact and value are so intertwined that you can't separate them, whether you're in one discipline or the other, because they basically inform the other. So if the facts are giving you what's kind of happening and what you're seeing, but then the value is like, what are you going to do with now those facts? And scientists need to know what to do with the facts that they're discovering, and humanities need to know the facts so that they can like better inform their values to kind of go with it.
You all, others can weigh in as well.
I can go. I think that it's important to have a balance between the 2, because if you solely rely on facts, then you could end up with a conclusion that nothing really matters, morality is out the window. But as we read in the book, even most atheists don't believe that. They don't believe that anything just goes. And you don't need religious text to tell you that, torturing someone is wrong. And I think that it's just built within us. And like Camille said, it's very intertwined, like fact and value. And on the other hand, if you have too many or too much value put into something and not much fact, then you just have like 2 sides yelling at each other based on pure emotion.
Yeah, I think that the overlap of them is really interesting, but also sometimes the necessary division between the 2 is an important factor we have to look at. And a big reason for this is because we have to know what question we're trying to answer before we go and look for the answer. So perhaps knowing where value comes from and knowing where fact comes from. In some sense, yes, there is that overlap when you start trying to find the underlying premises of facts, but you also need, how would I say it? You need the distinction to kind of know where to look and try to know what question you're trying to answer in some ways.
Yeah, are you thinking along the lines of there are a very large number of questions that we could possibly study and there's not enough time? So the value may be driving which things we think are valuable enough to do the studies on?
Yeah, exactly. So I visited a family friend's house once, and then we were talking about like observing facts. And something that interesting that came up is the idea of like, okay, tell me a fact. And then we just have so many facts like in the world around us. And this is an idea Kuhn talks about as well. We have like so many facts in the world around us that we need some set of values to orient what facts we want to focus on. And so I think that speaks to the interesting like underlying values that we kind of subconsciously ignore during like when we're trying to look at just facts.
And that goes for scientists as well, of course.
Yeah, I think that just like everybody else said, there is a lot of fact and value being intertwined, especially like I can see it as a mathematician, and I'm sure everybody else can see it in their STEM fields, but also in certain forms of communication. It's good to distinct between what you're approaching, fact or value.
So I want to pick up on Kuhn. Sam, you mentioned him, and he also came up in the book. One of the chapters was a brief summary of Kuhn, I think is a fair assessment. Thomas Kuhn, for those of you who aren't familiar, made a critique of science, perhaps, and one of his points was science is not as objective as we seem to make it out to be. Scientists have values that they begin with, partly to determine which questions they're going to study, partly to determine things like what counts as evidence and how are we going to debate about those evidences. So that comes to the notion of beauty from the talk, I think. One of the ways that physicists do decide which theories that they want to pursue is beauty. I will acknowledge that as a physicist. I love that physics is beautiful. And I have built into my training some experience of when I'm trying to solve a problem and it starts to simplify and it starts to become symmetric, perhaps, then I get excited. I think I'm onto something and it's probably going to be right. So I guess my pushback on that is, why is that a bad thing if we're not as objective as we say we are?
I think this was brought up in the book as well, but like when we ask someone, like maybe a kid, what 2 + 2 is, like he's not going to sit there and list all the possible answers, right? He's just going to say 4. He has to go to sleep, get to school the next day. But the point is that like we need simplicity to move on, to progress, right? So if we're stuck on all the minute little details, like I know in physics or engineering classes, you have, what's the answer to this question given? There's always like a given that this is the ideal situation, or that the constant of gravity is 9.8 meters per second squared, right? So, and that isn't like consistent throughout, but we just accept those things so that we can move on to the more important things.
Could you repeat the question, like what the question is one more time?
Why is it a problem if scientists do use aesthetics as opposed to just being as objective as the received version says scientists are?
I think at some point we have to accept certain things because as the book talks about skepticism, if we're skeptic about everything, we will eventually get no answers. And so at some point, of course, like we can continue to look for facts, but there's some things that we just take as they are. For example, like the faith in mathematics. Like there are certain axioms that we believe are true even though we can't prove that they are true or false. But in order, just like Isaiah was saying, instead of focusing so much on those things, we accept things are true in order to get to the greater things in math.
I think a potential problem that could arise, say, from science using aesthetic as a way to guide their discoveries, if we think skeptically, I guess is what you would say, is that there's this underlying, again, there's just this underlying belief almost, or this trust that the world will make sense and will be beautiful and will be symmetrical. And then that starts to lead into, wait, why do we believe, like, kind of like the question, why do we believe that it's going to be beautiful and why do we believe that it's going to be symmetrical? And so that then turns into philosophy, and you begin to really start having these big questions of, well, is there some God, some designer, or is it just all somehow minutely and very intricately happened to align this way? And so I think the danger could be just the assumption without realizing what that assumption really means for what you're thinking in the rest of your life. Because if you're assuming science is symmetrical and beautiful, but then you go around and say that everything's subjective, or like truth's more subjective and science is objective, then there starts to be a dissonance there when you look into them deeper.
Yeah, I want to add to that too. I think the direction of the relationship is important, and in some ways it's like all truth should be beautiful, but maybe not all beauty is truth. And so we've been reading recently Galileo, and combating the idea that the solar system revolves around the Earth. Personally, I would think it's beautiful to think that other planets revolve around the Earth, but there's also beauty in the truth that they don't. And a pure appeal to beauty in that respect could cause us to miss some of the potentially even larger beauty that we could discover if we were open to the more scientific study.
We have a follow-up from the audience for Camille's question, or your comment. Yes, we are sometimes making assumptions that we think that the nature is going to be beautiful, perhaps because of a belief in God. But it is an assumption, I'll grant that. So the question we have from the audience is, for the students, what are some of the philosophical assumptions of your majors that you are aware of and that should be addressed more by your field? Good question, whoever submitted that one. Maya's looking to pass that on, Mike.
I can jump in on that. So I'm a psychology major and a bio minor. So in the psychology field, there are many different schools of thought in psychology, and each thought comes with its own set of presumptions. So a really clear example is behavioralism. Like, people's behavior is determined by the things outside of them. That in psychology, there kind of is a lot of subscriptions to underlying assumptions, and then trying to create behavioral interventions based off of that. So the behavioral approach would be, if we can adjust people's behavior, then they'll have better psychological outcomes. Or then there's also the physiological approach, which claims that people can be physiologically treated for psychological diseases. The cognitive behavioral approach, if we fix people's thinking, we can better their psychology. So each one of these schools of thought subscribes to their own presumptions, which I find kind of beautiful because it kind of creates a unifying field in psychology where you have different people all studying their different, all assuming certain things. and then creating assumptions based off of that.
To what extent are those assumptions discussed in your courses when you're learning about these different theories and approaches?
I would say psychology does a good job at them because we study them piece by piece. I think they can get easily convoluted, like if you're learning about all these different types of therapies. But because normally we study like each specific part individually, I think they do well to communicate. Like this is predicated on the assumption that we have things in our unconscious that we need to get out of our unconscious, for example, and so on.
Thinking about my classes for science and for biochemistry and biology and chemistry and all of those things, I think there's this underlying assumption that we can discover and we can observe some truth about the world, and we can know that this is how the world works. But I don't think, because kind of Galileo talks about this in his book of how we can, well, he takes it from a Christian perspective in that because God created this world and God created our minds, he created our minds to be able to inquire and be curious and discover about his world. But I think that's still an assumption that I was taking a physical chemistry class last semester. Shout out to Dr. Roth. It was just so interesting to be sitting in that class and to be thinking everything, all of these unique pieces apart, are bound to come together and actually make sense. Why do we think that? How did we come to that assumption that if we try our hardest to put these together, that they're actually going to be able to be put together and you're going to be able to discover new things? And I think those type of assumptions are not addressed in our science classes as much. Like, everyone just assumes, okay, yeah, science can make sense of the world. We can figure it out if we try to. And I'm like, but how? That's kind of an assumption in and of itself.
And now you're doing philosophy. I think I'd actually like to pass this question to Mitch, too. What are some of the assumptions of philosophy?
Yeah, so one of the things I found, it's a little easier for me to answer that because I came into philosophy from the STEM area. So I spent a while being perplexed. Like, why are you doing this the way first of all, what are you doing? Class, what is knowledge? Well, knowledge is justified true belief. No, it's not. It's this, that, or that. And I'm well, what is the data here? Like, what are you using to, like, who decides what the right answer is, and what's the method behind finding the right answer? It's like, well, is it just kind of a democracy, or like everything? Like, what do most people say? What are their intuitions about what knowledge is? And it's like, well, why would you care? Let's look in a dictionary to see. That's not really what we're at. So it actually, some of the methodological assumptions that went into that were in philosophy when I came to it, it took a while for me to actually figure out what those were, and in some of those I just think are wrong.
Could you give an example?
Yeah, to think that, so for example, one of the assumptions that, and this goes all the way back to Plato, so I actually disagree with Plato on this, is so that there are these, there's something out in the world or in the independent of us and what we think called knowledge or called justice. Like at first I was like, okay, we're trying to find what it really is, and then someone said, well, we're trying to find out what God thinks it is. Okay, that's fair too, and I think that that's legitimate, but I think oftentimes what we're doing is we're just trying to find a definition in what matches our intuitions And you have this whole cottage industry of philosophy saying, or debating over what knowledge is. And I may be wrong, maybe that's a great thing to do, but thinking that there's this one objective definition when all you're really doing is analyzing your own concepts, which is actually what they call it, conceptual analysis. And I don't think it's entirely, I think it's important, I think it's useful, but that's a big assumption that I'm like, I don't think that they never got me on board with that one.
Maya or Isaiah, do you want to weigh in or you want to pass?
I think a lot of the times, like, scientists take credit for, like, the discoveries or inventions that they make, and I think in my head it's a little bit silly because I imagine God as, like, sort of this person that developed this Lego set, and it has manuals to it, and let's say, like, a human being, like, manages to follow all the steps and put the whole thing together, right? Would God go, oh my gosh, good job? Or would he go, like, that's what it's meant for? And I think that's my sort of approach at it. Like, we kind of just discover these beautiful things that God already set into the world. And yeah, that's just my own perspective on it.
I feel like from a physics perspective, there's so many assumptions that we make in class. I know, like, a lot of our homework assignments, you're given certain pieces of an equation, and then the rest is sometimes up to assumption. And so I think that's something that we do address in the physics department here at Azusa, and something that I'm, like, slowly getting used to, of assuming a lot of things.
Yeah, I'd agree with that. As a physicist, I have to make assumptions. There are not enough facts to know what I need to know, so I got to fill in the gap somehow, and I do the best I can with the tools that I got. Okay, so I want to bring it back to the book a little bit, and for the sake of our audience who haven't necessarily had a chance to read the book, the very brief summary is in large extent a critique of some of the new atheists who are following what may be called scientism, making this claim, the Hawking claim that you referred to in the talk, that science has made it unnecessary that there is God. So kind of the first portion of the book, you're focusing on science making bigger claims than it actually has warrant for. Things like the string theory. We have people claiming it's true, and it is the way that the universe came to be, but yet we have no actual evidence for it, other than this sense that it's beautiful. So they're overextending their claims, and you have many other examples. And then the second portion of the book is a critique along the lines of, if there is no God, then what's the basis for morality? And that may be really dangerous. So on the first part of that question, the skepticism, how skeptical should we be of the science? I think it was you, Camille, mentioned a bit ago that at some point when we're being skeptical, we still have to act. So where do we draw the line between questioning what we know and just acting on what we know as the best evidence that we currently have?
I think there is a lot of merit to, in some ways, having faith in things. I really appreciate the description of faith as betting on something, in a way. I'm going to live my life as if this is true. And a lot of times what happens with that is that the evidence comes after the acceptance of it. And it doesn't work the opposite way. So in other words, like, you can't obtain a list of facts and then come to a conclusion, but in some ways you have to adopt a premise and bet on it. And as you live it out, the facts kind of can come to support it or come to deny it. And I think that's something really beautiful to consider when we're looking at like theories or models that explain things. Is sometimes we just have to propose a model and subscribe to it and live it out. And through the living of it, you either come to continue to support it, or it just gets replaced later on by something more accurate and closer to the truth.
I really liked what Sam said, especially like relating it to math, and something that we use is like proof by contradiction. Sometimes you do have to assume something and then go throughout your proof and then find out that it's wrong, and then you've proved something else. Or you can have something and believe it to be true and then go on trying to improve it and come to a conclusion.
I think Descartes had a really interesting take on this. He, in his search for true, distinct, and clear knowledge, he had to basically rid himself of all assumptions and everything he believed before so he could start from the ground up. But in order to still live in this world, even though he's taking this journey, he said, I'm still going to live, even though I'm going through this process, I'm still going to live based on how my culture and the men of sense around me live, because if I just don't believe or I can't live in a world if I am skeptical about every single thing. It's just not practical. So even though he was going from the ground up and trying to rid himself of all assumptions and conclusions or possible errors in thinking, he was doing that in his mind, but I think on a daily basis he still made it clear that no, I'm going to still live though as if or according to where I'm at in the culture I'm at, with the people, with what the people who dictate and have common sense say, so that I can move forward. So I think it's an interesting balance.
And at least Descartes knew that he was making assumptions and acting to the best of his ability. So Mitch, I'm curious, have you had any pushback from atheists who may have responded to your book and your critique that they are not being skeptical enough?
No, but partly, like, other than my mom, you guys are the only ones that have read it. So, and she's not an atheist. I haven't. I mean, I haven't had anyone interact with me. I mean, like Amazon reviews, but
That might be a bot.
Yeah, well, it was like someone said, I thought this was going to tell me how to be an atheist. It's like, well, there are subtitles you could read. But I think the question that you asked is like, I mean, that's one of the hardest questions to answer, and really kind of at the centrality of what it's a lifelong quest to figure out, all right, you have to assume some things, you have to believe things, I believe in order that I understand, I mean, that's something that you have to do, and everyone has to do that, even to do that. And then, so you have to believe something, but you can't be too skeptical, so at the very least, you want to stay on the road. You can't go into one of the ditches. Now the question is, okay, now I know the project is staying on the road. Where on the road? Like, where's the road? Where, when am I getting into the ditches, and where do I need to stay? And that is something that and you'll never, so you have to figure it out, okay, who am I going to trust? Like, there's so many things, most of the things we don't know, the whole COVID thing, like what data am I going to trust? Who am I going to, what news source? And it really becomes this, it is a serious issue, and a lot of what you're doing and what you got as what you're learning and what you're teaching is how to navigate and stay on the road and have the confidence that, oh yeah, no, I can know stuff even with some uncertainty. It's not an either or, where postmodern kind of, I mean, there's a lot to learn from quote unquote postmodern flashlight. I think there's a lot to learn there, but it can't be, oh, we don't know anything. And it's like, well, you just kind of, it's like when you pick up a toddler and they just kind of go limp when they don't want to do, that's their resistance. We're just going to, and I think that's kind of that's a cheap and easy, it's self-refuting, and it's just easy. The hard part is staying on the road and doing it in a way where you have to know that there's a tension, and you have to act, you have to believe, it's a lifelong goal.
Yeah, I could make a case that it's more intellectually honest to say that, yes, I believe some things in science, but I also have assumptions about who I think God is, than it is to say, no, I just don't believe any of that. I'm claiming to be skeptical when I'm actually not being skeptical of my own beliefs. Okay, I'm reading another question from the audience now. The question is, you mentioned the idea in the talk of the Pythagoreans and how mathematical equations could reveal the beauty of things. What are your thoughts on the golden ratio, which is a ratio that some purport achieves a certain aesthetic, whether it be in nature or in man-made things as well? So I think that's for you, Mitch.
I think it's beautiful. Yeah, no, and that is one of the examples that has been used throughout history as, like, look, nature. You see that golden ratio manifested in nature quite a bit, and it's also beautiful, this notion of proportions and going back to it. So it's one of the many examples, but yeah, it's like it's certainly one of the most famous.
Can we share what the golden ratio is? For the audience members who may not.
Asking for a friend. See if I'm going to get this right. I'm going to phone a friend in the audience.
Thanks for putting me on the spot. 1 plus square root of 5 over 2, right? Oh, that's not what you meant. What's the golden ratio? If you draw a big rectangle with a smaller one inside, then you want them to be similar to each other, so that if you rotate one, blow it up, it'll be like the big one. That's a terrible explanation,
What
but
if we Googled, do we have
it shows up.
to-
I turn this off. It shows up in the ratios that you can measure in the growth of a lot of things in nature and in different artworks and sculpture and architecture. And if you know the Fibonacci numbers, 1, 1, 2, 3, 5, 8, 13, if you take the ratio between two consecutive ones, as you get higher and higher, it approaches the golden ratio. Picture is better than 1,000 of my words, I know.
Thank you, Bryant. That's Dr. Bryant Matthews, everybody.
It starts to approach pi as it goes up and up and up. Right? That's the idea. I read that, but I've also.
Okay, so I'm going to bring you back in a little bit. Thank you. Try to land it a little bit. So with the theme of bridging two cultures, I want to really get to the meat of this to the extent that we can in the next 5-ish minutes. We had this claim from C.P. Snow that the sciences could be done better if they understood the humanities better, and vice versa. How does that work? How would knowing humanities make the sciences better? How would knowing sciences make the humanities better?
One thing that comes to mind is it goes back to the very long time ago. Know thyself. And if you know what you're studying and you know what assumptions you're making, and especially, feel like I see this more on the science side of, like, being aware of what assumptions you're making and where you're approaching a problem from will just make you a better scientist, and it will make you more, like, well-rounded. And more like a well-rounded person. A really quick point is like when Nietzsche announced, famously, he pretty much said, God is dead and we have killed him. And one thing he followed that with is pretty much saying like we've lost all direction in all other areas. He starts saying like, where are we moving now? Where are we going? And so it's quite a beautiful description in my opinion, because I think what he did is he connected the importance of God in all other areas in science. And if we try to deny one, it's kind of like cutting a branch off of the vine. It's not going to live for long. So yeah, I think gaining understanding of both is super important.
I think as a science and humanities major, it just makes me appreciate more of the other, and it also gives my brain a break when it's tired of the other one. But I think it just, I don't think I could like science as much as I do if I didn't have this type of humanities education alongside of it. And I don't think I would have appreciated humanities at all if I hadn't paired it with this science education as well. And I think even reading, also in physical chemistry last semester, a book about entropy, and he would go into, he didn't go very much in depth into entropy, but one of the things he was saying about statistical something, statistical mathematics, and that describe basically where entropy and his equation came from. It's through these concepts of chemistry that we get to. Now this is more religion, I guess, but religion is kind of tied into humanities. You would get these glimpses of God and of, oh wait, this aligns so perfectly with who the character that I know God to be, and just this idea of miracles, and how everything, entropy is basically a bunch of statistics, and so it's just so there's such a high probability that all of the air molecules are not on like one side of the room, but are diffused. But technically, since it's just a probability, there's that one chance that they could be all on one side of the room, and so the other side of the room would suffocate. But that doesn't happen because of the probability of things. And so that just kind of, for me, it just made me think about how, okay, even in the design of science and the world itself, there's still room for God to move, and which is a possible explanation for where miracles could come from, in the sense that maybe it's not contrary to science, it's just super science, you know?
I think going back to sort of like God gifting us all this wisdom and knowledge about how our world works. For instance, if medicine wasn't invented back then, they probably would have thought that, you know, God miraculously healed this person, and that may have been the case. But the whole thing about that first part, how there's no longer a need for God because science has the answers to more and more things. I think that it's really important that the interplay between fact and value come in, because although we can find answers to all these different phenomena in our world, it doesn't mean that God isn't behind all of it. So I think that it's really cool that we're now like bridging this gap and seeing that there are truths to both sides, and taking the time to really understand both sides will help us to develop a better understanding of our world and possibly how God works within it.
So just a couple of examples of how knowing philosophy can influence physics in a big way. I mean, first of all, going back to the quantum mechanics and, you know, Bohr and Einstein debating, about the nature of science. God doesn't play dice. That's the famous quote from Einstein. So Einstein's thinking about the world. He has these assumptions about the world and the way it should be. They're philosophical assumptions, and he's bringing them to bear on his choice of what path to take for this in this revolution. And Bohr's like, no, we need to do that. And Einstein was actually against, to some degree, a certain interpretation of quantum mechanics. And then there's also now the contemporary. Well, we just talked about this when we were talking about the Large Hadron Collider. Should we build? Should we spend $20 billion on a new collider? Depends. Is symmetry? Should we follow symmetry? We're not seeing super partners now at the Large Hadron Collider. Is that because it's a dead end? Well, and so you have to figure out. So all of those are, whenever we're talking about, all right, well, how do, we're at the fork in the road. Oftentimes you can't you don't have more data by which to make that decision. And there you go. You're coming back to the philosophical question. So knowing that you're doing that, even if you make the wrong choice, you're going to be more likely to make the right choice if you know that you're doing that.
I'm going to go a little bit different direction on why it's useful for STEM people to know some humanities. Scientists and engineers are people. and so understanding humans more allows us to understand ourselves better, allows us to know which questions we're going to value more, which questions we're going to study. On an engineering aspect, it may allow us to do a better job of considering the needs of the people that we're trying to serve with whatever we're inventing. And then I'm even going to push further than that. That as Christians who are also STEM people, the humanities are utterly critical for us. Because I don't really know how to do Christian discipleship without lots of the skills that the humanities develops. Things like being able to read a text and interpret it with a community. Just utterly critical for life, which is really what we're trying to do with the sciences, to enrich life. Okay. Anyone have any closing, parting thoughts for us?
That was a good one.
I've been working on that one. All right, so we're going to go ahead and wrap it up. We have a couple of just quick announcements, and I have messed up Louise's slides, so I will fix that. We wanted to briefly acknowledge the sponsors for this event, the supporting structures. I'm going to get this wrong if I don't read my list. The Scholarship in Christianity in Oxford Supporting Structures Grant. This has also been supported by the Center for Research in Science, the American Scientific Affiliation, APU's Office of the Provost, and the College of Liberal Arts and Sciences. Thank you to all of those sponsors for this event. I also wanted to give a brief plug for coming up soon, January 27th, the American Scientific Affiliation's Winter Symposium. This is an online event. I encourage you to sign up for this. Dr. Elaine Howard Eklund is going to be presenting that. She's a sociologist who has lots of expertise in the relationship between science and religion. So if you enjoyed this event, you probably would that one as well. To close, thank you again, all our speakers, and thank you all of our guests, and Mitch especially.